Hello, my name is Dow Codes, and welcome back to our design pattern series. Today we're going to be talking about the dependency injection, or DI. And dependency injection, kind of a high-level summary, is a design pattern where an object receives dependencies rather than creating itself. So an external source provides it. And dependency injection is really important and key as a design pattern because it forces your code to kind of conform to a lot of different really good design principles just by having DI. So by inverting your dependencies, you kind of have to fall into certain patterns or else the code just doesn't work. But let's get into what the problem the DI solves. So this is a really stupid contrived example that AI gave me, but this is an order service and it creates its email service in the constructor. So when you try to go and test that or change the implementation of email service, order service is then the one that has to individually change how it constructs it. And this is true if email service is spread throughout the application. If the constructor on email service then needed to take in maybe an API key, maybe a domain or a response, it now needs to be changed throughout all the different places where it's constructed. So the DI solution, what this solves is that instead of the email service here being constructed by the order service, and now the order service is the thing managing the email service, the order service actually just receives a notification service. And the interface there is an important distinction. Now, you don't have to use interfaces there. There are frameworks where you can just do singletons of concrete classes, but part of the dependency injection pattern is to use an interface. We'll get into why a little bit later. So get into the three types of dependency injection. So the first is the most common is constructor injection. So like we saw above, we have a email service. Here we have a user controller. This is very standard where a controller takes in a interface service. Then later down the line, it can call the user service throughout the class. The property and setter, you can also inject it here. Really, I prefer the constructor method. Primary constructors make these things really nice. And then the final one, though, is method injection. If you only ever need it for a single method and you don't want it throughout the whole class, the first thing I would think before I use method injection is to think, is my class doing too much? If there's so many methods, but there are still really good cases for this to be. So C# is built on the idea of dependency injection. There is the Microsoft's extensions.dependency injection that basically all major apps, any well-written .NET app will and should use builder.services.add scoped of some sort, right? This is a very common thing. We use it in our Breakpoint app, but there are different types of service lifetimes in .NET. So the main ones are transient, scoped, and singleton. So scoped is the most commonly used one for things like APIs because it's scoped to the request. That means when you come in with a request, your database context, those things, they're not being shared across requests, which is really nice for API calls. You don't want someone else's API call to mess with yours. Now, a transient is if you have a new or you need a new instance every single time. So the difference there is if a request calls a repository and then it calls a repository later in the service call, it goes to that same repository again. But if you needed a transient one where every time I go to this object, it's new, it's stateless, then that's what transient is. And singleton is a single instance for the entire lifetime. So configuration, caching, logging, these kind of things need to be shared, but singleton is a pattern that should be used sparingly, and you should know when you should be using it, not just because, oh, well, it's the simplest and I can get it to work. So it's just a little lifetime visual, but like I was saying earlier, dependency injection, once you start using it, it supports so many really good code quality things. So SOLID is a acronym for how to write good software. But SOLID, the D, is dependency inversion principle. And DI is basically the framework to do this. So DI, dependency inversion, so not DI, but dependency inversion, dependency injection versus dependency inversion there's a difference. Dependency inversion is saying that high-level modules should not depend on low-level modules. Both should depend on abstractions. And the reason we do this is because if the low level changes, the high level should not be impacted and vice versa. It should flow down the system, right? So I don't care how my notifications are being sent out, whether that's text, push notifications, or emails. If I want to swap those implementations out, I don't want my order service, which is a higher business layer application service, I don't want that to depend directly on sending an email, right? That doesn't make sense. Now, the other thing is that DI makes testing really easy. You should be doing unit tests. This is a good thing. And when you start doing unit tests, when you don't have dependency injection, it can be really hard, right? The order service previously, if you knew up an order service is the system under test, you then have to write some iffy code of if testing, don't send emails, or things like that. But if you can inject in a mock with an interface here, and I'll do a little nicer here, you then no longer have to worry about how this order service is going to mess with the notifications. So some other common interface patterns that it kind of helps you go into is when you have a DI framework, your interfaces become more important to be fine-grained, because send email, send SMS, send push become a big service. It's a fat service. But instead, you segregate them so that each one becomes like an iNotification service. And then it's just send notification. And then you have integrated things underneath it. And then you could inject the correct one at the correct time, right? Maybe you have an Azure function that processes email queue. Then that one, you would inject the email service. Now, factory is another one that we've covered before, but factory patterns make it really easy with DI, because in the testing, you can then mock the factory. But the other side of that is you can inject the factory itself as part of the dependency injection. And sorry, just went to the actual code. Now, some DI anti-patterns to avoid. In C#, you generally do not want to use a service locator or the service provider as the actual thing in the class. Now, there are some cases where you need a runtime thing to be able to go to. And then, like we talked about earlier, too many dependencies, right? This God service, you're probably doing too much in it. But so some key takeaways: DI, it's receiving dependencies, not creating them. And the big one, depend on abstractions, not conquering classes. Even though most of the time you can have a single implementation of an interface, it's better to have interfaces for testing and other purposes. And when you do want to extend your application, when you don't have a bunch of concrete classes all over the place, it's easier to do so. So constructor injection is preferred and the most common one. And then these other ones are just great. And it's really, like I said, a foundational pattern for clean architecture. So I'll show an example recently. So my Breakpoint app is out and deployed, and I had a video processing service. Locally worked great. But when I deployed to a Linux container, it was using Windows-specific video processing. So what this led to is OpenCV# had dependencies on my Windows. And there are Linux versions, but I couldn't get it to work in Azure Function. So because I had this, it was segregated away from the rest of the application. I just said, okay, I'll just write a new implementation. And then on runtime, when I do my builders, and I'm using the singleton pattern because it's an Azure function and I want them to be single threaded because of the way processing handles, I get to just inject different ones. But then my Azure function, who uses the video processing service, if you just go find all references, I just pass in this, and I don't care who's doing the video processing. But that's going to be a little bit, and there's some great resources that I'll link in the bottom about DI, the solid principles, and some of the popular DI containers. But that's going to be it for today's design patterns. Hopefully you enjoyed. Happy coding.